Okay, good morning, students. This is a class of geotechnical engineering. So, so we have entered in the second module of geotechnical engineering, that is permeability of soil. So, till last class, we have discussed about the basic definition of permeability of soil, that is, what is permeability of soil, and what Darcy's law of flow of water through soil mass. Okay, so we have discussed all these things. We have also discussed about seepage velocity, discharge velocity. Okay, and we also know about the laboratory test required for determination of permeability of soil. That means coefficient of permeability of soil. That is constant head permeability test and falling head permeability test. So we have discussed in the last class about that. Today, we're going to discuss about some factor that may influence the rate of permeability, or you can say the coefficient of permeability of soil. Okay, so there are there are numbers of factors. There are numbers of factors that may affect the permeability of a particular soil. Effect means because due to some factor the permeability may increase, due to some factor the permeability may decrease. So we're going to discuss about some factor. Okay, so let me first share the screen. Wait. Screen is visible, right? I believe this is visible. Okay. So I hope you can see this. Okay. So this image I have taken from a book of soil mechanics and foundation engineering by B.C. Punmia. Okay. So I have taken this material directly from the book. Okay. So here you can see, if you concentrate on the title, that is factors affecting permeability. Okay. So the factors, I'm not going to give you a detailed explanation of all these things because not all these things are required, but some things are important for you at the beginning. So that things I'm going to discuss with you. Okay. So the factors affecting permeability. Okay, somebody is want to join. Wait. Okay, so here you can see the factors affecting permeabilities are what? Sorry. Yeah, so factors affecting permeabilities are what? First, you can see here grain size, then properties of pore fluid, void ratio of the soil, structural arrangement of the soil particles, entrapped air and foreign matters, and at the end, adsorbed water in clay soil. Okay, so here you can see 6 factors are given as per these books. These 6 factors may affect the permeability or coefficient of permeability of particular soil. So you can also remember this formula. Okay, this formula is given by Poiseuille's law. Okay, and this formula is derived from this Poiseuille's law, and Poiseuille's law adopted a flow of water or flow of fluid through soil pores. Okay, so comparing that particular formula with Darcy's law, that is Q is equal to KIA, that we already know. So finally, the final equation for coefficient of permeability is come like this. So you don't need to go for how it come, derivation is not needed. just, and even the formula is also not important, but why I have mentioned here, if you can remember this formula, that is the value of K is equal to ds square multiply gamma w by eta multiply e cube by 1 plus e multiply by c. Okay, now if you can remember this formula, you can indirectly you can memorize the factor affecting permeability. Okay, now here you can see ds represents what? Ds represents your size of the soil particles. Okay, size of the soil particle. Okay, now what is gamma w? Gamma w is your unit weight of water divided by eta. Eta is your what? Eta is your viscosity. Here you can see eta is your viscosity. I think related to viscosity, you all know these things, right? In hydraulics, you know these things. Viscosity is what? It is a resistance force against the flow of water, isn't it? And then E is what? E is your void ratio. Okay, and C is nothing but a constant, and the value of C is actually considered approximately equal to your 100. Fine. So whatever, if you can remember, if you can concentrate on this in this formula, you can see this value of K is this value of K depend on this diameter of this soil particle. So we can say K is that is coefficient of permeability depends on diameter or size of the particle. So from this you can find out the first factor, that is grain size. Then properties of pore fluid. Now what do you mean by pore fluid? To know about pore fluid, you have to know what is pore. Pore means what? The vacant space or void. That is the vacant space, the voids available in a particular soil mass. They are also known as pore space. Okay, and if that particular pore space are filled with water or filled with any kind of fluid, that fluid will be known as pore fluid. It may be water, it may be another fluid. Okay, okay. So from this gamma w and this eta, these are what? Gamma w and eta is the properties of pore fluid, isn't it? So we can say K also depend on this properties of pore fluid. Okay, and void ratio of soil. So even from this formula, you can say K, that is the coefficient of permeability, is directly proportional to E cube by 1 plus E. Okay, so from this formula, you can find, at least you can remember three factors that may affect permeability, that is grain size, properties of fluid, and viscosity. Okay, so we are talking about only these three. Other things also important. We are going to discuss them also. Fine. So let's discuss the first point. That is the first factor. That is your effect of size and shape of the particle. Okay. Now here you can see the permeability varies approximately. Here you can see, right? My mouse is not working properly. It's just a second. Okay, can you see this slide? Can anyone please respond? Can you see my
yes, sir.
It's visual, right?
Yes, sir.
Okay, take it. Actually, so we are discussing about first point, that is effect of size and shape of the particle on permeability of soil. So here it is written here, permeability varies approximately as the square of the grain size. From where it is written here? From this formula again. From this equation you can get it, that is coefficient of permeability, or simply permeability, varies approximately or proportional to the square of the grain size. You can see d square. Okay, and Allen Hazen in 1892 he proposed a equation or proposed a relation between coefficient of permeability and effective size of the soil particle. And this Allen Hazen equation also very important from exam point of view. Okay, I'm not only talking about this your regular exam, I'm even talking about your competitive exam. Okay, so in some competitive exam also this frequently asks about this Allen Hazen equation. Okay, so you have to remember this Allen Hazen in 1892, based on his experiment on filtered sand of particles sizes between zero point 0.1 to 3 millimeter, found that permeability can be expressed as K is equal to C multiply D10 square, where C is what? C is just a constant, okay, and approximately equal to 100. And D10 is what? D10 is your effective diameter or effective size expressed in centimeter. Okay, so about effective size, it is already discussed in the first module, that is in particle size distribution by sieve analysis. In that particular chapter, we already discussed about D10. D10 is what? D10 represents a size in millimeter, isn't it? Usually, D10 represents size in millimeter such that 10% of the soil finer than this size. But in this formula, especially in this formula, this D10 is represented in centimeter. Okay, so don't be confused here. In this formula, D10 you have to put in centimeter, and this coefficient of permeability. I think I already asked you in the last class about to find out the coefficient of permeability, the unit of coefficient of permeability. So here you can see the coefficient of permeability is expressed in centimeter per second. Okay, and here diameter D10 is represented in centimeter. Okay, so in some exam, even one problem may ask about to find out coefficient of permeability if for a particular soil D10 is known to you. Suppose D10 value will be given to you. Okay, then you are asked to find out coefficient of permeability. Then you have to use this formula K is equal to C D10 square, where C is your just a constant equal to 100. The value of C may not be given to you, but you have to know C taken the assumed value of C is what? 100. Okay, so 100 multiply the given value of D10 whole square, you will get the approximate value of K. And this formula is given by Allen Hazen in 1892. You have to remember this. Okay, okay. So from there, only these things are important for now. So this, like this, we can say the effect of grain size on permeability of soil. Next, we can say the effect of properties of pore fluid. So when you say effect, properties of pore fluid, so what are the properties of pore fluid? Like unit weight of water or unit weight of fluid or viscosity. These two factors may affect the permeability of soil. I am repeating, that is unit weight of water and viscosity of water, or you can consider any fluid. Okay, so here you can written here that permeability is directly proportional to the unit weight of water. Okay, so from this equation, from this Poiseuille's equation, you can also express that is coefficient of permeability is directly proportional to the unit weight of water. Okay, and inversely proportional to the viscosity. So you can see, and it is inversely proportional to viscosity. Simple is that. Okay, so from this formula only you can define the relation between properties of fluid with permeability of soil. Okay. Okay, so I'll go next. So if you compare two soil having different permeability, so we can relate the coefficient of permeability of two different soil having coefficient of permeability of K1 and K2, and that particular soil or particular soil having the fluid carrying a viscosity of N1 and N2. So this is the relation we can derive, that is K1 by K2 is equal to eta 2 by eta 1. That is what happened. Okay, so you can derive also this like this. Okay, so if for two soil this viscosity of fluid is given, or for another soil, for one soil coefficient of permeability is given, so we can also find out the coefficient of permeability for the other soil by using this relation. Okay, so also you try to remember this also. Okay, so from here also you can find out the coefficient of permeability is inversely proportional to the viscosity of the fluid or viscosity of water. Okay, next point, the effect of void ratio. So we already discussed about effect of void ratio. That void ratio is directly proportional to this formula, that is E cube by 1 plus E. Simple is that. No need to go in detail here. Okay, so we can find out coefficient of permeability is directly proportional to the E cube by 1 plus E. Okay, from the formula that is already discussed in the last image. Okay, where E is what? E is your void ratio of the soil. Okay. 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 So next, okay, can you see the slide? Can you see the screen? Can you see the screen? Please respond.
Yes, sir.
Okay, take it, take it. So, okay, fine. So we are discussing about the factors affecting permeability, right? So here the fourth factor, that is fourth factor. So that is effect of structural arrangement of particles and stratification. So to understand this, we have to understand what is stratification. So stratification comes from stratified soil or layered soil. Okay. So what is layered soil? So I'll just explain here. So you can also search in Google, so you will find out. It's very easy to understand. So in nature, suppose I'm talking about this ground surface. Okay. Suppose this is a ground surface. So below the ground, you can find out different type of soil. Okay. Say up to this level, the soil is clay. Yeah, I'm just giving you some example. Okay. From up to this level, another soil type will be there. Another here also another type of soil is there. So how can you distinguish between this type of soil? So how can you from the index properties of soil? So if the index properties of the soil of this layer, suppose this is a first layer, see this is second layer, so this is third layer. So it will go on like this. Okay, the layer of soil will go on like this below ground surface. Okay, so how can you distinguish between these layers? So you can signify that the properties, that is the index properties of the first layer is different from the second layer or also different from the third layer. So that means each layer have their unique property. Okay, they are not similar. That's why they are called layered. That these are the layer of soil. So this kind of layered soil are called as stratified soil, and this kind of situation is known as stratification. Okay, so this, I think you got this idea, right? So structural arrangement of the particles may vary at the same void ratio depending upon the method of the deposition of or composition of the soil mass. Now, how this stratification or this layered soil may affect the permeability. Now, as I already told you, suppose this is a ground surface. Suppose this is a ground surface. Okay. So water have a tendency to go in this direction, that means in lateral direction, or water have a tendency to move in this direction. Wait, huh? Class okay. So suppose this is a x direction, this is a z direction. Okay. So in this direction, suppose the coefficient of permeability, wait. So these are the layered soil, okay, layered soil, and water moving in this direction or water moving in this direction. So suppose this is in this direction, the value of k is represent x, k, x, okay, and value of coefficient of permeability in this direction represented by kz. Okay, so this value, that is coefficient of permeability for this soil mass, that is for this stratified soil, is not same, is depend on the direction. That means this kx may not be similar with kz. Have you got the idea? That is, stratified soil mass have marked variation in their permeabilities in direction parallel and perpendicular to the stratification. Okay, that means if water is flowing in this direction, that means we can say the flow is parallel to the stratification. If water is flowing perpendicular direction, you can say the water is flowing perpendicular to the stratification. And if you consider kx in this direction and kz in this direction, vertical direction, so we can say, so it is proved that kx, that is a coefficient of permeability in along or parallel to the direction. Raw class out solely raw. So the coefficient of permeability parallel to the stratification is may not be similar with the coefficient of permeability in perpendicular direction. Got my idea? That means when it comes to stratified soil, K, the coefficient of permeability depends on stratification also. That is the main point that you have to understand. Okay? Fine. So these things are already discussed here. You can read out all these things from here. Okay? Next point is your effect of degree of saturation and other foreign matter. Now, in simple statement, we can say the permeability is greatly reduced if air is entrapped in the voids, thus reducing its degree of saturation. Okay, that means if the soil, if the voids are entrapped by air, okay, that means there is no way to go, there is no way of water to pass through. So indirectly, it is reducing the permeability. That's why it is given as the permeability is greatly reduced or greatly decreased if air is entrapped in the voids, and this reducing its degree of saturation. Okay. Another term is your foreign matter. Okay. Now foreign matter like organic matter. Okay. So organic foreign matters also has the tendency to move towards the critical flow channel and choke them up, thus reducing the permeability. Now you can imagine a soil mass having voids, okay, having soil solid, water, all these things, okay, and if that particular soil mass also containing some organic matter. Now if water is flowing in a particular direction, because of the flow of the water, some organic matter also follow that particular direction, and that organic matter may block the voids and reducing the cross-sectional area of the voids. So if the voids are reduced, water cannot pass through the voids, isn't it? So indirectly it reduced the permeability of the soil. That's why it is given as organic foreign matter also has the tendency to move towards the critical flow channel. Critical flow channel means the channel or the path taken by water within a soil mass, okay, to flow and choke them up. That means they block, organic matter block the voids and thus reducing the permeability. Okay, this is all about the fifth point. Next, number 6, that is effect of adsorbed water. Now, there is a two kind of water may attached with soil mass. One is adsorbed and another one is absorbed. Okay, there is a very thin difference between adsorbed water and absorbed water. One starting from AD and another one starting from AB, absorb and adsorb. Okay, so absorbed water are that particular water there which are occupied the voids. I'm talking about absorb, A, B. Okay, so absorbed waters are those water they are occupied by the voids. But what this adsorbed water, that is the A, D. Adsorbed water are those water. These are actually part of the structure of the soil. That means they are actually structural water. Okay, or you can say if the particular water get lost, the whole structure will get distorted. Okay, and especially this adsorbed water mainly we can exist in fine grained soil. Okay, so the adsorbed water surrounding the fine soil particles, especially we are talking about clay particle. Okay, or also silt also, but especially we are talking about clay particles. Okay, so adsorbed water surrounding the fine soil particles is not free to move. That means they are act as a part of the soil. They are not like a pore water, they are like a structural water. So adsorbed water surrounding the fine soil particles is not free to move and reduce the effective pore space available for a passage of water. That means even the adsorbed water which cannot move, but they also block the space or block the voids. They don't move, but they block the voids. And the pore water cannot pass through it. Okay? And reduce the effective pore space available for the passage of water. Okay? So, like this, the adsorbed water also have an effect or have effect on permeability. Okay? So, all these four factors we have discussed till now, that is क्या क्या डिस्कस किया हमने okay, so we have discussed about grain size, properties of pore fluid, void ratio, structural arrangement of soil particles, entrapped air and foreign matters, and adsorbed water in clay soil. So these six factors have an effect on permeability of soil. Okay, so mostly they have decreases the permeability of soil. Okay, so this is all about today class. We have discussed about factors affecting permeability of soil. Okay, chalo theek hai. So I'm going to stop here. Okay, so I'll not wait further. I'll just take the attendance because we don't have much time, because there is a next class also for you. Wait, let me stop the recording also.